Okay, hello everyone. This will be our last video going through some of these problems. Again, I'm going to do it a little bit quick, but just so you can at least see me work them out and see it at any point. So let's just hop in for unit 7, 8, 9. So combining forces. If I want to combine forces acting on a box of some sort, we have to look at the actual result of those two forces. So the first force is 10 pounds in the north 20 east direction. So remember bearings north and south. That's north pivot 20 degrees east. And then the other force acting is 30 pounds of force at a 45-degree angle in the same direction. So remember that force 1 and force 2 is just broken to sine and cosine components down. Now here's the only thing. Because this is bearings, my sine and my cosine are actually flipped. So you could convert them into 70 degrees and 45 degrees respectively, but I'm going to keep it in terms of 20. So force 1 is 10 sine 20I plus 10 cosine 20j. And force 2 would be 30 sine 65, not 45, I plus 30 cosine 65j. If you're not sure why the sine and cosine get flipped here, just think about drawing the triangle with the angle in its place, and then you'll see why sine is now the x composition and cosine is now the y composition. So when I add them together, I get 3.4i plus 9.4j, as well as 27.2i plus 12.7j. So the result is, since they're both going in the same positive directions, I just add them together. So this is the resulting vector, 30.6i plus 22.1j. Now to find its length, its magnitude, I'm just going to basically use Pythagorean theorem on those two values. You should end up with 37.7. And then to get the angle, you do tan inverse of 22.1 over 30.6. And that should get me about 35.84 degrees. Now, if I want to convert that into bearings, both are sending it north and east, so this would be a northeast problem. However, when you do tan inverse, you actually find the opposite to the bearing. So to find the actual bearing, it's northeast, but I would do the complementary angle here, so 54 degrees. Okay, so the angle in the triangle is 36 degrees, but the bearing direction would be north 34 east. Now graph. So this is graphing a polar equation. So now sometimes you remember it's easier to find the angles that we already know we're going to use. Plug it in to get the radius. So if I plug in 0, pi over 2, pi, 3 pi over 2, I get the coordinates 1, negative 1, 1, 3. So at those angles, I'm going to plot those points respectively. So at 0, 1, that's right about here. At pi over 2, it's negative 1, so remember that goes the opposite direction. At pi, it's 1, and at 3 pi over 2, it's 3. So if I look at the order, that means I have a Limassol curve that does something like this. One important thing to maybe potentially remember as well is that we talked mostly about Limassol curves and as well as those pedal graphs. So remember that if I had, let's say, graphing r equals sine of 2 theta or r equals sine of 3 theta, the number of pedals depends on whether it's even or odd. If it's even, you double. So there are 4 pedals on that one. If it's odd, you keep it the same. There are 3 pedals on that one. So those are 2 types of graphs. Graph the polar coordinate for 5 pi over 6. So on the 4th radius ring, I'm going to go to the 5 pi over 6 answer, which is right here, right? The 4th radius ring. The next question is state it with a positive radius, but angle that's greater than 2 pi. So I can keep the radius the same. I'm just going to add 2 pi. So 4, and then if I add 2 pi to this, I get 17 pi over 6. And then secondly, find the polar coordinate. Since we have the angle, remember it's actually just using sine and cosine coordinates. So 4 cosine 5 pi over 6 for x, 4 sine 5 pi over 6 for y. And so those coordinates end up being negative 2 root 3 and positive 2 afterwards. Dot product, pretty easy, just a weird equation. So remember dot product is v dot u or w. That's take the numbers in front of I and multiply them, and then add the numbers in front of j after you multiply them. So I get -3 plus -3, so the dot product is literally -6. Given that v is 2i minus 4, find the magnitude. So this is actually just doing the square root of the dot product, but this is also doing Pythagorean theorem, so you could think of it either way. So 2 squared plus -4 squared, take its Pythagorean theorem version. So that's square root of 20, which is 2 root 5. Graphing this conic section. So I know it's a conic because it has both x and y squared. So after I move the 2 squared, or the 2 to the right, divide everything by 2, I get x squared plus y squared over 2 equals 1, which means this is an ellipse with a center at 0, 0, an x radius of 1, and a y radius of root 2. So I'm just going to do my best to try to graph those coordinate points. This is a little bit too small, or too big actually for the graph, so I'm going to count the 5s as 1s, and I'm going to count the 10s as 2s. So again, my x direction is 1 and 1. My y direction is root 2, so that's approximately 1.4 and -1.4. So yeah, that's really it for the ellipse. No focus. It's not asking for focus, so we don't need to do that. Graphing our parameter equations. So I always think it's easier to graph these by getting the x, y coordinate points by plugging in. Now this one has an infinite time frame, so I'm going to say -1, 0, 1. So by plugging in those coordinates, I get 1, 2, 0, 3, and 1, 4. And if it's not already clear, to eliminate, I'm going to pick one of the equations to isolate. I'm going to pick the y equation because it's easier. And now I'm going to replace x with a y. We're going to replace the t in the x equation with y minus 3. So in case it's not clear already, it's now a parabola. So I have the point 1, 2, 0, 3, and 1, 4. So we have a parabola. And remember, we want arrowed directions, telling us which way to go. Same thing here with this conic section, because you see the sine and the cosine, it's kind of a giveaway. So I only have a set number of angles to choose from, so I'm just going to pick the relevant quadrant angles. So when I plug in 0, I get 2, 7, -2, 3, 2, -1, and then finally I get 6, 3. Now, if you remember how to isolate these, we want to basically get sine by itself here. So I get x minus 2 over 4 equals sine. Not theta. Whoops, t. And same thing here, isolate the cosine, y minus 3 over 4 equals cosine. And if you remember, the whole purpose was that we square both sides and add, because that's going to take care of the sine and the cosine, and I'm going to be left with x minus 2 squared over 16 plus y minus 3 squared over 16 equals 1. So this is actually a circle that's centered at 2, 3 with a radius of 4. So if I go to the point 2, 3, and I go out 4 over 4, you'll see that these points should line up with my coordinate points. The only problem with this is that the angle ends at 3 pi over 2. So it's actually not the full circle. So if we actually start at the first coordinate and wrap the circle around to the last coordinate, that's where I actually need to stop. So that's it. It's 3/4 of the circle, because it doesn't go all the way around through 2 pi. Now at the last graph right here, this is an ellipse, a hyperbola, and we can tell immediately because the x and the y squareds are both opposite signs. So I'm not going to go through the whole graphing aspect of this. Just make sure you know how to identify the shape and maybe complete the square real quick, and then you can go through and find all those parts. So remember to complete the square, x squared plus 8x minus 4y squared plus 2y equals 7. Okay, this is good as is. So if I take 8 divided by 2 and square it, that means I'm going to add 16 to the x component. which means I have to add 16 to the right. But remember with this one, I have to divide out -4. So this is going to be a little bit tough because if I divide 2 by 2, I get 1/4, and then square it, I actually have to add 1/16 inside of here. Not a really fun number, okay? But then on the other side, because I multiply by -4 first, I actually have to subtract 1/4. So really not the most fun. I know, math's always fun though, isn't it? It's never not fun. And I get 91/4, and then this is factorable, so I get x plus 4 squared minus 4 equals, or times y minus 1/4 quantity squared equals 91/4. And I have to multiply everything by 4/91. So my final equation is 4 times x plus 4 quantity squared over 91 minus 16 times y minus 1/4 quantity squared over 91 equals 1. I'm not going to ask you to graph anything that insane, but the idea is that now you should be able to find the center and the radius. The receiver of the parabolic television dish is 3.5 feet from the vertex, and it's located at its focus. Find the equation of the cross-section. So it's a parabola. Here's the receiver. Maybe it's a dotted line that comes here, but we know that this is 3.5 from the focus, which, remember, that's our p-value. So the way that I drew this, it's opening up. So that means it's a y equals x squared equation. And if you remember, the equation had 4p in front of the not squared variable. So by substituting 3.5 in here, 4 times 3.5 is 14. So I get 14y equals x squared. That's really it for that one. And now unit 9, last unit here, find the recursive. So again, recursive is a little bit different. A sub 1 is 2, because that's where it starts. And so let's look at the pattern. This is plus 4. It is times 3, but times 4, 6 times something is 14. That's really hard. But this is plus 8, and then this is plus 12, and then this is plus 16. So what I'm actually doing is I'm adding each increment of 4. So the way I would say this is I would say a sub n equals the previous term plus 4 times n minus 1. It's not n here because the first term is already starting at 2. So I had to preference it by saying that the second term has to add 4, and then everything gets an addition of 4 afterwards. Okay, there is other ways to write this sequence, but I found this to be the quickest and most efficient. All right, so finding the nth term in the arithmetic sequence and then find the 23rd. So remember, we actually have a general formula for this. That would be a sub n equals a sub 1 plus the common difference times n minus 1. See how I kind of used the previous formula in this case too? I just modified it slightly. So in this case, I am minusing 3 every time. My first term is 14, so a sub n would be 14 minus 3 times n minus 1. And then I would just plug 23 in. So a sub 23 is 14 minus 3 times 23 minus 1, which is 22. That gets me negative 52. Evaluate P12, permute 3 versus 10, choose 3. This is just using your calculator. This value should be 1,320. Just remember, go math over to prob, and you should be able to find it down there. And for C, it's 120. A professional basketball signs a contract beginning of a salary for $3 million for the first year, an annual increase of 4% per year beginning the second year. That is beginning the second year multiplied by 1.04. So this is a geometric sequence because we're multiplying by 1.04. Find the value of 7 years. So if I want the sum after 7 years, we have a geometric formula. It's the initial value times 1 minus r to the n for the number of years over 1 minus r. R is the 4% increase, so that's the 0.04. So I would do 3 million. 3 million? Yeah. Times 1 minus 1.04 to the 7th, divide that by 1 minus 1.04. Quite a large number to do this calculation. And that would get us the sum. Although, now that I'm rereading the question, it's actually not asking for the sum. So this is how you would find the sum. It's just asking for the 7th. So to find the sequence of the 7th, we have an even easier formula. Whoopsie, sorry about that. So you would do a times 1 times r to the n minus 1. So you would just do 3 million times 1.04 to the 7 minus 1, so 6. So you just put that in your calculator, that's it. All right, use properties of sums to evaluate. So remember, this just means I plug in 1 for I, and then I add the next number. So 2 cubed, and then 3 cubed, and 6 is my stopping point. So I just have to keep adding all these cubes together until I get to 6. And when I do that, I get 441. Now this one wants the total salary. Okay, there we go. I knew this equation was coming up. So 32,000, 6%. We've already kind of gone through this process. So to find the salary for any given year, you would do the 32,000 times 1.06 to the n minus 5. So to find the 6th year, I would do 32,000 times 1.06 to the 5th. And it gets me 42,823.22. Now to find the total salary, I would use that formula I just stated. So it would be 32,000 times 1 minus 1.06 to the 6th over 1 minus 1.06. So when I calculate that, I end up with $210.19. If the geometric sequence of a sub 2 is 5 and a sub 5 is 135, so that means we start at 5, then a sub 3, I do not know what that noise is, a sub 5, and then 135. That means I apply the common ratio 3 times. So what that means is 5 times some number cubed should be 135. So dividing both sides by 5, I get that r cubed is 27, which means r is 5. So we know that r is 5, so I just have to keep taking the 135, times it by 5 once to get to a sub 6, times 5 again to get to a sub 7, times 5 one more time to get to a sub 8, and I get 3,645. Lastly, find the probability of not picking a diamond or a face. So what we need to first figure out is what are the odds of picking a diamond or a face. And so when we think about that, there are 13 diamonds out of 52, and there are 16 face cards in the deck. So that's the probability of picking a diamond or a face. But remember that there is some overlap here. So we have to take away the probability of picking a diamond face card. And so that would be the jack of diamonds, the king of diamonds, the queen of diamonds, and the ace of diamonds. So that's 4 out of 52. So the probability of picking a diamond or a face is 25 out of 52. So then the probability of not doing that, not a diamond or a face, would be 1 minus that fraction, because that means everything else would not be that result. So that would be 37 over 52. Okay, so I hope that was helpful for units 7, 8, and 9. So go back and watch any of those videos for any of these questions, and feel free to check the answer key as well for more work. All right, have a good one. Good luck.